In a previous lesson, you learned about and worked a little bit with algebraic expressions. In this lesson, we are going to talk a little bit about equations and start thinking about working with equations. In algebra, an expression and an equation are not the same thing. The biggest difference between an expression and an equation comes down to the equal sign. Expressions do not contain equal signs. As soon as you put an equal sign into the statement, then it becomes an equation. So an equation will always contain an equal sign. There are different types of equations. Sometimes you might have an equation with just numbers. In that case, your equation would be true or false. So I could make an equation that looks like this. 2 plus 3 equals 5. That's an equation because of the equal sign. We also know that 2 plus 3 equals 5, so that equation is true. I could come along and make an equation that I know is false. 3 plus 3 does not equal 5. It's supposed to equal 6. So that equation would be a false equation, but it is still an equation nonetheless because of the equal sign. Sometimes equations have variables in them. So I'm going to change our equation again and make our equation x plus 3 equals 5. Now I have a missing piece of information that I would need to know to work with that equation. When you have an equation with a variable in it, like this last example, then that equation is also what we call an open sentence. It is a sentence because it is a number sentence. So a number sentence is any statement involving numbers and symbols in math. So it is a number sentence. The reason we call it an open sentence is because of this variable. So we have an opening or a hole in our equation where we're missing a piece of information. So that's why we call it an open sentence. So an open sentence is basically a fancy math term for an equation that has at least one variable somewhere in it. There are a couple of things at this point that you should be able to do to work with an open sentence or an equation with variables. When we have an equation, we talk a lot about solving equations. So you will be asked to solve equations quite a lot in algebra. So when you're asked to solve the equation, specifically what you're asked to do is to find what we call the solution, or in other words, the value of the variable that makes the equation true. So if somebody handed you an equation and says solve this equation, they're really asking you, what number should I replace the variable with to make this equation work? So that value that makes the equation true, whatever you replace the variable with, that we call the solution to the equation. There are a couple of different ways that you should be able to work with solving an equation at this point in the year. One situation would be a situation where you're given the equation and you're given some possible solutions that you have to test out to figure out which one is the correct solution. So, for instance, maybe you are given this equation. 18 equals n plus 7. And you're given some options. Is the solution nine, 10, or 11? Now we have three possible things that could be the solution here. So the only way to find out if any of these are the solution is to test them out. So remember, the solution is the number that we replace the variable with that makes the equation true. So the only way to find out if these work is to actually go through and replace the variable with each of these and test it out and see if it works. So if we take the first number, 9, and replace the variable n with it, then we would get an equation that looks like this. 18 equals 9 plus 7. Well, 9 plus 7 actually equals 16, not 18. So that means that does not work. It gives a false statement. So the answer is not 9. So now we would try the 10. 18 equals 10 plus 7. 10 plus 7 is 17, not 18. So that means that doesn't work either. So that is another false statement, which means the solution is also not 10. So then we would move on and we would try the 11. 18 equals 11 plus 7. 11 plus 7 is 18. That is a true statement. So that means that the solution to this equation is 11. If you're given possible options for the solution, that's how you can go through and test them out to see which one or ones. Some equations might have multiple solutions that work and make the equation true. Sometimes you're not always given options, though. Sometimes you might just be given the equation, and then you might have to use some logical reasoning to figure out what the solution is. So a second example might be something like this. Maybe you're asked to solve 4x minus 1 equals 11. Now this time I'm not given any numbers that I can fill in and test out, but I can use some logical reasoning. So remember, solve means that I am trying to find what number needs to go right there where the variable is to make this statement give me an answer of 11. If you have a very short one-step equation, many times you can look at it and figure out mentally what's going on. Another informal strategy is to work backwards. The reason I say informal is because right now we're not going through formal steps to organize your work for solving an equation. But as we move through the year and we do more work with equations, we will develop a more formal process. So right now we are being very informal just to get you working with the idea of what it means to solve an equation. So this rule is telling me that I have to take my answer according to order of operations, multiply it by 4, subtract 1, and then I get 11. So I could work backwards. If I multiplied by 4 and subtracted by 1 to get 11, then working backwards, I would need to undo the subtraction by 1, which gives me 12. So now I know that 4 times my number before I subtracted the 1 must have been 12. Well, from here, a lot of you are probably, hopefully, starting to notice the answer. 4 times a number equals 12. If you know your multiplication facts, then you would know that 4 times 3 equals 12. So the answer must be 3. So that's the solution. So if you are given different options to try, like you were in example 1, you can test each of them out to figure out which one works. If you're not given possibilities, you can still find the answer informally by thinking about what you do to your variable to get to your answer, and then working backwards through that process. One last thing that you will be asked to do in this lesson with equations is an extension of another thing that you've done earlier in this unit. Earlier in the unit, you did a lesson on keywords that let you turn a statement in words into an algebraic expression or a statement in symbols. We can also do this with an equation if we add in one more keyword. So you should already have a list of keywords for addition, subtraction, multiplication, and division in your lesson notes. When we have an equation, we have an equal sign. There is a keyword that means equals that can let you turn a statement in words into an equation. The keyword for equals is the word is. For example, let's say you were given this statement. The quotient of a number and 4 is 9. This statement has a keyword in it for equals right there, the word is. So that tells you automatically there is going to be an equal sign in this, which means it's an equation. That equal sign also splits the statement into 2 halves. This is going to be one side of the equation, and this is going to be the other side of the equation. Since we know that it is 9, that means that whatever we do is going to equal 9. So we'll have a 9 on that side of our equation. The other side of the equation is going to involve translating that expression, the quotient of a number and 4. Now this is the piece that we were working with in a previous lesson. So hopefully this is feeling a little bit familiar. Quotient was one of your keywords from your lesson notes. If you remember, quotient means to divide. So the quotient of a number and 4 means to do the number divided by 4. So adding in the is 9 part, we end up with n divided by 4 equals 9 once this is all translated. So this is very similar to what you were already doing with expressions. We just added in one keyword, is, that now lets us do the same thing with an equation instead of an expression.